Hello everyone, and welcome to today's workshop Marine Data for Coastal Monitoring for Copernicus Marine Service. So my name is Gail Enafsterbik and I'm a training officer at Mercator Ocean International and I'll be your host for today. So I'm a little bit blue from yesterday evening, but don't pay too much attention to that. As you know, we will have a two-day workshop, and today we will have more introductory session where we'll tell you about what the Copernicus Marine Service is about and what sort of data you can find and what sort of applications you can do with the data we provide to you. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible ways. So first, please do not use the chat you see on your right-hand side for the question. Use the in-week chat you can see on the right. So in a general case, don't use any Zoom features. Use only what you see on the web page event. So for the chat, don't use it for question. You can use it for small talk or to say hello to us. But if you have a more technical question or if you have any other question, we will use the Q&A section on the website, as you can see. So it's on the top bar of your page and you will find the Q&A button like here. And if you click, you will see an area dedicated to the Q&A. And that's where you can ask our speakers your question today. You will also find a section reserved to the polls, the survey. You can answer it at any time of your convenience, and if you want to modify your question later, you totally can. So don't worry. So concerning our speaker today, so we will have many interesting presentations. We will start with an introduction, so I will give it to you, to the Copernicus Marine Service, and then we will go to a more in-depth presentation about the products Mercator provides to you with Valentina Junta. And later we will have Cedric Jourdan, from the user support. He will tell us about the e-learning materials and how to access the user support pages on the Copernicus website. And lastly, before a 10-minute break, we will have Anaïs Perrin, also from the user support. She will give us two presentations, the first one on a demonstration of MyOcean Pro, and a second one on the Copernicus Marine Toolbox. After the 10-minute break, we will have 4 presentations about specific application of these Copernicus marine products. We will have Katerina Spanuzaki from the Coastal Marine Research Laboratory in Crete Island. Then we will have Dr. Augustine Moses Jegabir from the University of Eastern Finland. Then Trang Shaw from the University of Paris-Saclay. And finally, Riccardo Martellucci from Italy at the National Institute of Oceanography and Applied Geophysics. So it promises to be a very interesting morning, and I hope you enjoy it. So now we will jump right through the first presentation, which is a little overview about the Copernicus service is about, just to introduce you to it if you are not familiar with the service yet. So it's a program created by the European Union. So it's a European fully funded program dedicated to the observation of the Earth and to better understand different systems of the planet. It includes 6 services. So atmosphere, marine environment, and land monitoring, and also 3 services for climate change, emergency management, and security. It provides information and free of charge open source data products about all these different systems. And obviously the marine service focuses on monitoring the marine environment. So how do you access the service through its website, Marine Copernicus? So it's free to access the website and download any product There you will find an extensive catalog of products. All of them are scientifically qualified and they are user-driven, so they are constantly upgraded and improved. And is also taken into account the experiences of users of the service. We provide several kinds of data. It provides data on the blue, the green, and the white ocean. So the blue is about all the physical components of the ocean, so currents, temperature, sea surface elevation. The green ocean is more the biogeochemical component of the ocean. So as you can see, plankton, nutrients. And lastly, the white ocean, well, it's ice, so ice coverage, ice velocity, all the frozen part of the Earth, and that's it. Then, oh, sorry. You can find these are just a few examples, and in terms of temporal and geographical coverage and the type of data the Copernicus Marine Service provide, it is quite varied. So it includes in situ data, satellite observations, which are used to validate model data. And then you can find data that are measured right now, what we call real time, but also from the past all the way back to 30 years, what we called multi-years data. And we provide forecast 10 days into the future. And also in terms of geographical coverage, we do cover 5 areas or 6 regions. So we have the global region all around the world and 6 smaller areas around Europe and in Arctic. We also provide specific products like ocean monitoring indicators or data related to the climate. In this case, the monitoring indicators are key variables that help us understand how the ocean is now, what the health of the ocean is. They are also accessible and free of charge, and they covered the past 30 years. You will also find in the Copernicus Marine Service website a visualization tool, what we call My Ocean Viewer, and you have three versions of this visualization tool. So the Learn, the Lite, and the Pro. And later we'll have a presentation to show you how you can select a project and then see it in a very fun way with Anais. And you will see it's very interesting and this gives another perspective to the data. Besides data, we also provide information, and one of the ways we do that is by publishing a yearly report on the state of the ocean, and we also provide Ocean State Report Summary, where we try to target more or less scientific communities, so more policies maker and the media or just the general public. And to make sure that the information gets to everyone, we do that by creating 2 pages called the Ocean Explainers and the Ocean Climate Portal, where we explain some oceanographic concepts or current threat that the ocean is facing, and we try to explain it to everyone. So also the Ocean Climate Portal just gives a perspective on the indicators key variable of the climate and the ocean, but in a more accessible way. So as you can see, we try to reach a bit of everyone, and it's the data that we provide and information. It responds to different needs or market. So as you can see, it goes from science and innovation to coastal services and lots of subjects. For example, today you will hear about 4 practical applications of the data we provide, but in the website, you will find many other examples, and we invite you to visit our website and learn from this example. And if you are a use case yourself, we also invite you to submit your project. We are always interested to learn more about how the data has been used everywhere. And so beside this, we also provide training and webinar as now, and we try to make sure that the data is not only available, but we can help people use it. So we organize workshops like this one. We also have hackathons and other events to try to engage with the users. So that's all for me for today. I hope we got a little glimpse of what the service is about, and now we will dive a little bit more into the product itself and then later on into the specific applications. So I'm inviting Valentina to do her first presentation about the product. The floor is yours.
Thank you. Hello, good morning to all. I'm very excited to be here to give you an overview of the Copernicus Marine Service products and all the kind of data that you can find here. So I will start my presentation just to, as Gael mentioned before, there is a single access point to all our data products. So in our main portal, you will find many different links and information, but if you want to dive into the data, there is one that is called Ocean Products. If you click there, you will have access to more than 250 scientifically qualified products and ocean monitoring indicators. So as Gael mentioned, our service is user-driven. That means that we take into account the feedback from users and we try to improve our products based on what they need for their applications or work. All the data is in a netCDF format. Again, this is open and free for everybody. So we divided our offer in what we call blue, green, and white ocean. So I'm going to explain a little bit more what these families mean. So for example, for the blue ocean, we refer to all the variables that describe the physical state of the ocean. So you will find information regarding temperature, salinity, waves, wind, sea surface height, velocity, but also information regarding mixed layer depth, sea surface density, tidal velocity, and many indicators that are computed using this data. So you can find data coming from models, satellites, and in situ as well. And the spatial resolution, it can range from 2 kilometers to 25 kilometers. Temporal resolution, it can be hourly, daily, and monthly means. We also provide 10-day forecasts every day. And we have data sets that have 30 years of data, and all the data is being updated daily. We also have what we call the green ocean, which are the variables describing the biological and biochemical state of the ocean. So for example, you can find information regarding the chlorophyll, light attenuation, turbidity, so plankton, nutrients, oxygen, pH, but also information such as reflectance, and many other variables as well, and also indicators. Again, you can find these variables, they come from models, satellite, and in situ data. And the spatial resolution that you can find for our products for the green ocean, it can range from 100 meters to 25 kilometers. Again, same temporal resolution. It can be hourly, daily, and monthly means. We also provide 10-day forecast, past time series up to 30 years, and all the data is being daily updated. So regarding the white ocean, those are the variables describing the life cycle of floating ice within the polar region. So you can find information regarding sea ice velocity, snow, albedo, iceberg, sea ice thickness and concentration, sea ice age. So many variables and indicators that you can use. So this data comes from models and satellites and not from in situ. The spatial resolution that you can find, it can range from 2 to 25 kilometers. It can be, the temporal resolution can be hourly, daily, or monthly means. We also provide 10-day forecast and long time series up to 30 years, and all the data is daily updated as well. So as I mentioned before, we have three main sources of data coming from satellite observations, in situ observations, and model data. So for satellite observations, we offer two different levels of information with what we call level 3, which are daily composite products along a single or multi-sensor. And then we have L4 products, which are daily interpolated, and you can find weekly and monthly composites. Then we have observation data, what we call in situ data. that comes from different networks and platforms. So it can be from Argo, gliders, from research vessels, from moorings, XPT, and many other instruments as well. And then we also offer model data, which are 3D numerical representation of the ocean, which assimilates what we call real data, which is mean satellites and in-situ observation, to improve the accuracy of the outputs. So if we dive a little bit into these three main sources of data, so for model data, we offer, from here I'm just highlighting three of our global models, one for physics, one for wave, and one for biogeochemistry. So for physics, we have the global model that it has a 1/12 degrees resolutions. It can be hourly, daily, and monthly means. The variables that you can find for these products are temperature, salinity, currents, sea level, mixed layer depth, and many others. It offers 50 vertical levels, so from the surface up to 5,500 meters. Data can be available from 2020 to up to 2024. It also provides 10-day forecast. And then we have our global model for waves with the same resolution, the spatial resolution, but the temporal resolution is hourly. And you can find information regarding the wave parameters from the total spectrum, such as significant height, period, and direction, and then the following partitions as well. It's offered data from 2021 up to 2024, and also 10 days forecast. Finally, we have our global model for biogeochemistry, which has a 1/4 degree of resolution. The temporal resolution can be daily and monthly means, and you can find information regarding chlorophyll, nitrate, phosphate, dissolved oxygen, primary production pH, carbon dioxide, and many other variables as well. It also offers 50 vertical levels up to 5,700 meters, and data from 2021 up to 2024. And 10-day forecast as well. Just to mention, these are our global models, but if you're interested in having a look at the data that we offer for the European seas and the Arctic region, we also offer these regional models, and this product can start at spatial resolution of 2 kilometers. Regarding satellite data, so for this part, I selected two products that we have for the Mediterranean area. So one is the biogeochemical satellite observation, which it has a 1 kilometer resolution, daily and monthly means. And you can find information regarding chlorophyll, primary productivity. And of course, this is satellite data. So that means that you can only find information at the surface of the ocean. And the data can be available from 1997 up to 2024. And this product has daily gap-free data and climatology as well. And then if you would like to have something that is more high resolution at the coastal area, we have high resolution coastal products coming from the Sentinel-2. So these ones have a resolution of 100 meters. It can be found daily, so it's the temporal resolution is daily. And you can find information regarding chlorophyll, suspended matter, turbidity, BPP, upwelling, radiance, and many other variables as well. And it can be found from 2020 up to 2024. As I said before, these are coming from the sensor Sentinel-2 for a 20 kilometer coastal zone. And these kind of products are not only available for the Mediterranean Sea, but also for all other European seas and the Arctic region as well. So for in-situ products, we divided our products in two big families. One is the multi-year family, and then we have what we call multi-year near real-time family. So the multi-year family is updated every 6 months, and the scope is more global. The quality mode that the data is being processed is delay mode, and the target is usually one variable. So we have products, for example, for carbon, BGC, sea surface height, temperature and salinity, currents and waves. And then what we have the other family, that is what we call multi-year near real time, that is had been updated every hour. The scope is global, but also regional. And the way that is processed is that you have delay mode, and then plus real time. So when delay mode is not available, we have this real time data. And if the target can be one or more variables, so we have different products for the different European seas, so Arctic, Baltic, Black Sea, Mediterranean, and so on. We have one for the global as well, and then for the currents as well. So just to highlight one of the products that we offer for in situ. So here is the global ocean in situ near real-time observations. So these are quality control observations. They are hourly updated. That means that you can find almost near real-time data here. And it's distributed by our in situ TAC center within 24, 48 hours from acquisition in average. All the data are collected through different platforms and networks such as Argo, Oceansites, EGO. And then the variables that you can find for this specific product, it can be temperature, salinity, sea surface height, velocity, sea surface wave significant height, chlorophyll, and many others as well. And it's very nice because in our visualization tools, you can see the platform from which of each data points are coming. So as I said before, all our data is scientifically validated. We do offer information regarding quality products. So if you would like to know more about how the data is being processed and computed, so you can go through our documentation. So we have two specific documents for informing the product and data quality. So one is called the quality information document, and then we have what we call the synthesis quality overview, which is an overview of the quality per variable. And then if you need more information regarding products and data sets, you can always have access to the product user manual. And just remember, we have a OAI for each of our products, so you can use this OAI to cite the product in your publications. So that is all from my side. Thank you.
Thank you very much, Valentina. It was really a nice presentation. We're starting to have lots of questions on the Q&A. We will answer all of them after Cedric and Anaïs both presented, but keep posting your question. Don't worry, it will be answered. Okay, so now it's Cedric's turn. And I let you take the floor.
Hello, everyone. I don't know if you can see my my screen.
Yes.
Yes. Okay. The website. I cannot see myself, but okay, no problem.
Yes. Yes.
So welcome to the Copernicus Marine website. I will give you an overview of the user corner section at the top right of the main page. In the user corner section, you will find several boxes. The first one is a getting started page. So if I click on it, you will find a sum up of the offer and an operational path to handle our services and products. So search, visualize, download, be informed, learn, and if you have any question, to contact the support. The second box is the really important one because it will direct you to the help center and FAQ. So in the help center, several collections are available. You can search using keyword. You can browse, of course, the collection. If I want to go to have information about the download on Copernicus Marine Data, so I click on the collection, and I found you can find many articles available to download the data using the toolbox. You will have a presentation later using the graphical interface, etc. So this resource, online resource, is really, really important because many questions are answered in this resource. The third one is the user notification service. In this section, if it's okay or not, yes, you will find information on the operational events, so incidents, maintenance, improvement, etc. For example, if I move to the incidents, you can filter using the different filters. And if you click on the title of the incident, you will find more information on the incident. So it's important to know that you can create your own RSS feed using the filters, and so being informed automatically in case of incident of maintenance. So this section is really interesting as well. The third one is the next one is the user learning services. Here you will find, following the link next training, you will find information on the event organized by the Copernicus Marine Service, and information on the training sessions. So this is available in this section. Come back to the user corner. The e-learning materials. Here you will find the list of all the notebooks, Python scripts, etc., available regarding the Copernicus Marine Service. You can sort as well using the filters, beginner, intermediate, advanced, the subject, in situ model, etc. And the tool, for example, if I want to Jupyter Notebooks, the list is updated automatically, and you can access, clicking on it, you can access to the resource. I come back to the user corner. Or not. Yes. The product quality. So this section is dedicated, to the product quality of the products. You can sort by the color of the ocean, so blue, green, or white, for using the region as well. And I let you discover this section, but you will find information on the quality of the parameters, the product, etc. So it is more scientific section. The next section is the roadmap. Here you will find medium and long term in the change. Sorry, the changes forecast for medium and long term. So information in this image, and clicking on this button, you will have different cards with a specific color for if the change is related to blue ocean, green ocean, or white ocean. You can the date of when the change will occur. So I click, for example, in June 2024, because release occurred 2 days ago. And here you will have the list of the changes. If I click on the map, on the card, sorry, I have more information on the change and the impacted product. So go back to your corner. Clicking on the Get Inspired section, you will find information on all the we'll find examples, so use cases of the use of Copernicus Marine data. You can as well sort by region, country, or market. And clicking on the card, you will have a sum up of the use case, more details, and the product used for this use case. Next, to log in and register, because to download data, even if the data is free, the access, the service is free, you need to register. In the service commitment and license, you will you will find information on our commitments, information about the opening of the user support, for example, information like that. At the end, to contact user support, you can click on this page. You are informed that to contact the support, you have to need the widget chat at the bottom right of the page. I click on it, and here you will have direct links to for example, the Help Center. It is the same you've seen before. You can search in the Help Center, for example, I don't know, download. how to download or original files. For example, I click on the article, I can maximize the window. So this is direct link to the Help Center. You have as well information about the news. For example, when the toolbox is upgraded, information are listed here. And if you have any question, you can click on the messages, ask a question, and you first you will meet our AI agent, Blue. You can ask him a question. For example, can I be informed of incident? So it's going think a little, and then you will have an answer and the reference of the information. For example, you can find the information. You can check the user notification service, etc., and the many information automatically available in the Help Center. So you can, if it's helpful or not, but of course you can talk to a person if you are not happy with the answer, the Blue answer. So do not hesitate to use this feature, and of course do not hesitate to contact us in case of any question or comment. Many thanks for your attention.
Thank you very much, Cedric, for your nice presentation. Just to let everyone know, so your presentation and Valentina's raised many questions, so we'll be doing a quick Q&A before moving to Anais. So before starting, just to let everyone know that the certificate of attendance, replays, and PDF will be available between 1 week and 10 days after the event. So don't worry about that. And please use the Q&A section for your question and the in-week chat for just small talk. Thank you. So first question for Valentina. When you refer to wind data, does it refer to the true surface wind variables or the components of wind waves? Thanks.
Sorry. So we offer wind data coming from satellite observation and scatterometers as well. So these refer to actually true surface wind variables, so, such as wind stress and wind speeds as well.
Okay, thanks. Okay, someone is asking if the data of river discharge at the mouth are included in the Marine Copernicus services. I don't know if you know that.
To my knowledge, we don't offer river discharges data.
Okay.
No, indeed, this data is used to build the models, but not directly available in the catalog.
Okay. So we have also two questions from Anuj. The first one is he is wondering if the bathymetry data is part of the scope of Copernicus, and he also wants to know how can we access the data repository and is it publicly available and or open source. So I'm guessing the second one is about the single point access of the website, but for the first question.
So we offer bathymetry data. It is available in our catalog.
Okay. Okay. So Marco is saying that he's interested in wave data to run his model and for a specific area. So he wants to know if he can access actual variance density two-day spectra instead of parametric data. I don't know if you know that.
So I don't have a precise answer for this. My advice will be to select which of the products you are more interested in regarding waves and then go through the product user manual. So you will find more technical information regarding the variables that you can find for each data sets. And if you have a question regarding the quality, so you can always go to the quality information documents that will explain a little bit more. But if you still have this question, we are happy to try to find the answer for this.
Thanks.
There will be information to find, sorry, to where to find the product user manual and quality information document later with the presentation from Anaïs.
Okay. Okay, there is also a question about phytoplankton data. So do we have only microscopic data or also meta barcoding one?
So for this, I would suggest exactly the same.
Okay.
To go through either the product manual or the quality information document for the product offering phytoplankton data, and it will explain a little bit more regarding what kind of phytoplankton is containing in the product.
Okay. Are data about shipping included in your services, AAS messages?
So no, but we do have many interesting use cases regarding shipping, and they use many of our products. So I would suggest you go through the use cases section and then see the ones that they're using our data for shipping. So maybe you will have some ideas about how you can use our data for shipping purposes.
Okay. Thanks. Yeah, don't forget, if you have any question, you can look at the use cases pages, and there is plenty of examples about all of the data are being used. So don't hesitate. Okay. So where can we find more detailed information? So I guess this question is like you mentioned before, regarding the user manual. So
yeah.
Okay. Where do marine product begins mean height, water, spring, or is there another definition used by Copernicus for the land-sea interface?
So we do offer what I explained before. These are the Copernicus Marine Service product, but if you're interested in the land-sea interface, I will also recommend to have a look at Wikeo, which is a joint collaboration between all the Copernicus entrusted entities. So you will find there not only Copernicus Marine Service data, but also from the Copernicus Land Service as well. So you might find some interesting product as well. And there is another platform that is called Coastal Hub, Copernicus Coastal Hub, that also has a selection of products that it can be used for coastal purposes.
Okay. Okay. So there is plenty of question about data for India. So we have data for the India. It's on the global product, if I'm not mistaken. So you can find data for every place in the world, just not at every resolution.
Exactly.
Okay. So this one the same. Can the forecast provided by the service be used for marine ship navigation? Of course, yeah.
Yes, indeed.
Yeah. Okay. I think we'll be doing one or two more. What's the software name which is used for data analysis for ocean monitoring except QGIS, Jupyter? So, well, I guess you can use whichever programming language you want. I don't know if I understand the question correctly.
Yes, and Cedric showed before, there are many of e-learning materials that use different software and programming language such as R, MATLAB, or Python. So feel free to have a look at them.
Yeah. Okay. I think we'll be moving on to the Anaïs presentations. We will try to answer all the questions later at the second Q&A section, but yeah, don't worry, keep asking questions. We will answer them as much as possible. And so Anaïs, the floor is yours for your first presentation.
Thank you, Gail. Okay, hello, I'm Anaïs from the user support team of the Copernicus Marine. I will introduce you the main feature of the MyOcean Viewer Pro. So to access it from your home page, simply scroll down with your mouse and then click on Try Now in the Dive into our digital ocean box. So here you have your 3 different ocean viewers. MyOcean Learns, dedicated to beginners. The MyOcean Lights offers a few more functionalities than the MyOcean Learn. And the MyOcean Pro is the most advanced and the one we are talking about today. So here you are on the interface. As you can see, you can here first change the projection by clicking on the one of these arrows. That is make sometimes, okay? Here you have the North Pole projection and the South Pole projections. You can click and drag the map with your mouse and zoom in and out on the map using your mouse wheel. So the little eyes you can see next to the layers tell you whether they are displayed on the map or not. Blue eyes means the layer is visible. Gray means it's not. You can change the priority order of this layer by holding down with the little squares and then moving your layer up and or down. So by passing your mouse over the name of the variable here, you have access to, yes, you have access to the name of the product as well as the dataset. So in this presentation, I will focus here on the wet and sea. It's a shallow coastal sea that evolves to the rhythm of the rising and falling tides. This region is characterized by flat islands bearing rising above sea level. So here we will display sea levels anomalies data for this region, as well as the current velocity data. So first, to search for products through our catalog, you just have to click on Add Layer here, and you arrived on our Copernicus Marine Data Store, where near 300 products are present. We therefore have all products classified according to different categories: the most popular, the product recently opened on the MyOcean, the new in Copernicus Marine, and so on. So under each thumbnails, you will find information about the product itself. For example, the name of the product here, the data acquisition mode, if it's a model or satellites observation, and also in situ observation here, in situ. So you also find information about the spatial resolution. If it's a 3-dimension product, you will find the number of the depth level here, for example. The satellites data are generally only in 2-dimension. You can also find the product temporal resolution and some of this variable. So the filters column on your left allows you to refine your search by entering keywords or by entering a time period. You can also specify that you are looking for 3-dimensional data with the depth button here, indicate the depth at which you wish to obtain data. You can also click directly on the name of the available variables or enter your geographical area, etc. So here I will looking for data on the Sisyphus 8. So I click on Sisyphus 8 on the main variable sections, and I choose an area that may include our sectors in the area section, like the Atlantic North. So I will click on the satellite observation in the source section, and I will choose a product with a daily resolution here. So for this presentation, we are going to choose a product with the recent data. To do this, I can base my choice on the available time range of each proposed product. So I therefore choose the first product. So when I click on the product, I redirect to the project description page, where you can see an overview and a lot of useful information about the product, like the source, the temporal extent, the resolutions, and so on. So on the left, you have access to other tabs like notification that tracks all incidents, improvements, and maintenance in progress or past on the product. The data access tab here, which show you all the data set contains in the product. You also find an explanation on different download methods with useful links to our App Center. For each product, you will find the service, currently a variable, subset, files, maps. Subsets form links redirect you to the subset graphical interface. Browse links redirect you to the file browser to retrieve the original data, and links to our WMTS service. So by clicking on the small information button, you arrive directly on our articles of our Help Center. By linking with the chosen access mode. These articles are there to explain how to this download mode works. Okay, so you also have the contact hub, allows you to contact our Help Center, and then you have the documentation section here with links to the user manual, the quality information document, the sentencing quality overview, the license, and links to our articles on how to cite our products in your publication. So the user manual documents contains all the technical informations relating to the project, and the quality information documents provides informations on all of more scientific informations or informations relating to the mode of the data acquisition. So if you like the product, you can share it using the share icon on the top right. This button allows you to copy the URL address of the product. So to visualize the variables of the project, you just have to click on Add to Map, and you can then choose the variables of interest present in different datasets of the project. So note that only variables relating to the sea surface height are visible. To display other variables, simply click on All Layer here. So, but in our example, I will stay on the sea surface height above sea level. So I click on Add to Map. So for more visibility, we can delete the layers we are not interested in. Here, the clarify by clicking on the cross. And you can see 5 different icons are present. The download icon, which I'm going to present afterwards. The information icon returns a product description page. The layers icon allows you to change the open variables by another present in the product. The gear is used to customize the layer. And finally, the log button lets you apply logarithmic scales to any data that can be scaled. So let's first start by changing the temperature layer here by the current speed layer. So as I said previously, I will therefore click on the layer icon of this layer, and here you see all the dataset contains in this product. The syntax of the dataset names contains their indicates their contents, such as the type of the variable, here the current, and here the salinity, the spatial and temporal resolution. The ending 6H indicates data every 6 hours. The day at the end indicates the daily data set, and for monthly. I will therefore choose the daily data set, daily current data set here, and I will display the seawater velocity. All right. So let's start by changing the color scale of our variable to make the data stand up more clearly here. So to do so, you can use the gear icon, and you can modify the opacity of your layer. You can invert the color scale. You can also define steps by selecting the discrete color map. So here you can remove, add, and define different steps. So you can also define the minimum and the maximums values gradient. And you can also adjust the contrast of your open, your data window by clicking on the auto here. So this function analyzes the data currently displayed and select appropriate minimums and maximum values. You can also choose to hide or not the data out of bounds. All right, here. For the vectors variables, like the seawater velocity here, you can choose to the representation styles, if it's solid or solid plus vector or simply vectors. And for greater visibility, I will choose the vectors layer. And I also will change the color map. Okay, so here the bottom bar on your screen shows the time range in which the data is visible. So the whitest lines indicate common data availability for the two open layers. By zooming a little further, you can see we can even choose to display the data at specific time. The right and left arrow on your keyboard are shortcuts to display the data at the next time step in this dataset. Here is per day. So another scale is available on the right of your screen here under objects and settings, the depth scales. This is visible because we kept a three-dimensional data set open on your interface, the seawater velocity. So by default, the data display the surface data, but you can change these settings by clicking on the scale here. And to be more precise, you can use the wheel of your mouse here, up your mouse or the up or down arrow on your keyboard to display data every 10 meters. So above the scale, you have different objects that can be created. The point here, like this, up. The point, the line for the transect here, and also an area. And for example, I will up, 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 an area. So each object gives us its coordinates here, as well as the values of the open variables, but also the minimum and the maximum values for the line and area object. These variables are automatically illustrated as graph as function of time and depth for three-dimensional variables, which you also get an average over this object here. So graphs options are variables with the three small dots at the top right-hand corner of each graph. Extends all graph lets you display them in larger format. You can also adjust axis, lets you adjust the chart parameters. You can also download the graph display in a netctf, CSV, or SVG format. So to download our data, you need to log in to your website with your login and password. As a reminder, the registration is completely free. It will be asked you for your credential each time you want to download data if you are not already connected. So if, for example, in the setting, I will log out here, and now I can't download my data. I must connect first. So you can also delete some graphs here. You can delete the graphs and make another appear depending on the variables open on your interface. So under the area creation object, you will find the settings, allows you to log in and log out, change the base map colors, show toponyms, change the projections, and the uniques of the objects and more. So now let's move on to download data. So to do this, let's go to the download icon here of the variable you want to download. So here you need to fill the geographical area you need. We can either manually enter the coordinates or use the define on map options. So these options, you can draw your area of interest directly on the map by maintaining the left click here. You can also erase self-selection with the cross. You can also select a previous object that can be created. So, okay. You also have here the date range section. So you must fill in the time period you are interested in. Next to it, you have the indicated time period available for these variables in the product. Be sure to indicate dates including this one. So as the same way as the defined on map here, you can automatically select the date of your visualization by clicking on the map here and here, for example. For three-dimensional data sets, you will find the depth range section, which allows you to select the desired depth level. Okay, and for a data set containing several variables, you have an additional section called also download, which allows you to download several variables contained in the dataset at the same times. And here, for example, I will select the first geoid. So the final step is to download your parameterized data. So several options are offered to you. The download button to download directly from the MyOcean interface your subsetted data. And as long as the data does not exceed the limit of 800 megabytes. You also have the automate buttons, allows you to override this limit and download the subsetted data with our Copernicus Marine Toolbox. So 2 download templates automatically complete with your selections parameters defined previously are then proposed. One template to be executed in the command line interface and another to be executed on the Python interface. So we will come back to these templates during the next presentation of the toolbox. So, and finally, you have the browse files options to retrieve the original files as distributed by the producers. You can browse through different directories, generally classified by years and months. The original files contains all the data from the entire zone for the day. So it's then not a subset of data. So in case of problem, you can contact the help center by clicking on the small bubble here on the top right, talk to an expert, and then go to the message here and ask a question to Blue. So Blue, our new artificial intelligence companion, will use all our contents as well as articles to best answer your questions. You will always have the option to contact the member of the user support if the response provided by Blue doesn't suit you. If you have a question with the downloading data, please copy and paste here. Sorry, copy and paste here the template of your data up for helping us to find the error. So you also have the home tab here. Okay. Here, you are also in the home tab. You can also consult our article without leaving your page. For example, if you're looking for information on how to use the MyOcean viewer, you can directly enter your keyword in the search help here or directly on the help tab. So if I type MyOcean viewer here, I will find our MyOcean introduction article in which here at the you will find at the end a part in which we answer the questions that we are most often asked about the tool. So the MyOcean has also a sharing functionality by clicking on the icon here. You can then share the links of your visualizations with whoever you want, created an image or even a video and even an embed link to include your visualization on your website, for example. So finally, you have the information icon here, which details all the keyboard shortcuts you can use on the MyOcean. So, okay. So don't forget that we have some articles available on our App Center concerning the MyOcean viewer, but not only. The user support team is nevertheless here to answer your questions and help you if you encounter difficulties. Thank you.
Thank you very much, Anaïs. It was a really nice presentation. actually, someone asked about the recorded version, so don't worry, you will have the tutorial available in 1 week or 10 days, the replays on the website and on the YouTube channel. So, Anaïs, I'll let you take a short break if you want, and then you can,
Yes. Okay.
if you're ready, you can ask
Thank you.
the second presentation, and then we move on to the question. There are plenty of questions for you, actually.
Okay.
So whenever you want, you can ask the second part.
Okay, let's go up. Mhm. Do you see my screen? No?
Yes.
Oh, yes. Okay.
The PowerPoint presentation.
Ah, yes, good. So welcome in this second presentation. We will now talk about the Copernicus Marine Toolbox, our new data download tool. So the Copernicus Marine Toolbox is free, user-friendly tool designed to interact with the Copernicus Marine Data Store. This versatile tool provides access to complete metadata, full dataset, or specific subsets, whether digital models, satellites, or in situ observation. The toolbox lets you view and extract detailed information on all the variables, datasets, and projects and their descriptions. You can select and extract only those parts of the dataset that interest you in optimized format. The toolbox offers a wide range of simple and complex filters for opening some specific files via direct connection to the Marine Data Store. It's also give you unlimited use of the toolbox in terms both of the data volumes and bandwidth. In short, the toolbox lets you explore and download all the products available in our catalog without any quota restriction. So among the many benefits is the ability to download data with a significantly improved performance. This is due to the conversion of all dataset to analysis-ready cloud optimized format. Analysis-ready means that the data has been homogenized for easy use and interoperability, whether for time series or geospatial queries. So cloud optimized indicates the state-of-art technologies are used to store data optimally and enable fast parallel access. The Copernicus Marine Toolbox offers this new access service via original files. This service provides the original version of the data as supplied by producers via direct connection to the Marine Data Store. The Geo Series service provides a version of the data with a small chunk size for the time dimension and the large chunk size for the latitude and longitude dimension. It's optimized for analyzing large geographic domain over a short period of time. The time series service provides a version of the data with a small chunk size for latitude and longitude and a large chunk size for time dimension. Is optimized for analyzing complete time series over a relatively small area. So during this presentation, I will show you the main feature of the Copernicus Marine Toolbox and some concrete example to illustrate how quick and easy it is to download Copernicus Marine data using this tool. So let's start with the various toolbox functions. You have the logging function here, which automatically generate an encrypted file containing your logging details. The describe functions, which allows you to retrieve the metadata of the desired product and dataset. The gets functions enables you to retrieve the original data as supplied by producers. And finally, the subset functions, useful when you want to retrieve only part of the available subset dataset. The toolbox can be used both on the command line interface, such as Mambach Miniforce prompt, and a Python interface. So here, API A for application programming interface, such as Jupyter Notebooks or code editors like Microsoft Visual Studio Code. So let's start at the beginning and first visit our help center. So here you will find all the information you need about our services. So go to the Copernicus Marine Data Download here. and then scroll down to the Copernicus Marine Toolbox section. So here you will find all the articles about the toolbox. In the Getting Started with the Toolbox section, you will find our introductory articles giving you more information on what I presented earlier, but also all the articles you need to know about the tool. In case of problem, you have a subsection called Troubleshooting and FAQ. In this subsection, you will find our troubleshoot article, which lists known issues and provides solution. FAQ article with the question most frequently asked by our community. Reporting an issue or feature requests, which tell you how to do it, raise a problem or a request for development. And finally, the next milestone and roadmap, which inform you about past and future improvement. You can also view the change made of each version of the toolbox by clicking on the new widget icon on the bottom right hand corner of your screen. So let's assume that you have already installed the Copernicus Marine Toolbox on an isolate Python environment, and that you have consult and follow the procedure described in our installation articles. So if you need any help for these steps, you can consult our troubleshoots articles or contact Blue directly with your questions. And for example, if I ask to Blue, how do I install the Copernicus Marine Toolbox here? So Blue, our new artificial intelligence mascot, will then replay to content our articles and other resources. If you are not happy with the Blue answers, you can also always speak to a member of the user support team. So here in the main functionalities subsection, you will find articles on each the toolbox function for both command line and Python. For users who don't wish to work in Python, the toolbox is also available for other programs, such as R. All our articles dealing with the use of the toolbox with other programs are available in the use case subsection here. So please note that everything I will show you during this presentation is taken from our articles. So now I suppose that you have created your own Python environment in which you have installed the toolbox. You then you need to activate it via your command line interface, and in this case, the Miniforge prompt. So I will open Miniforge here, like this, and write Mamba activate CMT. CMT is the name of my Python environment. So for now, I'm no longer in my base, but in my CMT environment, thanks this previous command. To check the current version of the toolbox that I'm using, simply write Copernicus Marine version. Okay, I'm using the latest versions, 1.2.4. Let's take a look on one of the toolbox on list functions that doesn't require your logging details to be executed, the describe function. So this function allows you to retrieve metadata from the MarineData store to obtain information on these options available for these functions. First call the Copernicus Marine and then specify the function here describe, and add the help option to obtain an overview of all options available for this function. So each toolbox function can be executed with the helps argument here in the command line. On the left, you have all the options that can be integrated to your query, and on the right, their description. In view of time available, I won't go into further detail on this function, but I invite you to consult the related articles. So before proceeding with the functions allows you to download data, let's first launch the logging function of the toolbox. This functions allows you to create your identification file so that you don't have to enter your credential each time you want to download data. So it can be run both on the command line interface and on Python. So for the moment, I stay on my Miniforge. So you only have to execute this logging function once. I write Copernicus Marine logging here. So I'm going to be asked for my username here. I don't know if you, okay. My username and password, and be careful. Okay, be careful, the writing of the password is hidden. You will not have the opportunity to check your spelling. So the identification file is not created, and you can find it on your default directory, username in the Copernicus Marine folder. So, well, now let's go down to business, and we will now show you how to use the get and subset function of the Copernicus Marine Toolbox. So let's start with the get function by a command line. So get functions allows you to retrieve the original data as provided by producers using original file service. Many options are available. To know them, simply write Copernicus Marine get help here, and you will see all the options available. So the only mandatory parameters of the get function is of course the call of the dataset desired. At the very least, you should use the dataset ID option, or just I for short. So let's take an example of a dataset previously used in the MyOcean viewer demonstration. Here, I will use the browse files. Close. I will use the browse files to easily retrieve here the dataset name. So if I write here Copernicus Marine get my dataset, here, if I enter only the dataset name in my get command, the toolbox will try to retrieve all data it contains. But that's not what I want here. I only want to retrieve data for specific dates. And for example, in April 22nd to 24th. So I must add the filters option and specify my date. April 2022. All right, here. And I also add the option to indicate in which directory I want to save the files, the output directory option, or just O for short. So here the toolbox will then show me all the file it found and ask me for validation before processing with the download. Note that all the messages appear here are information message about the version used, about the part of the data in which we are looking for, a data set in which we're looking for data. The get function's default service use is original files, and the download start. So I confirm that download, and then check in my folder if there is my data. And okay, that's there. So let's move on the toolbox next function, the subset function, which allows you to extract only data you want. But at this time, let's take a look on how to use the toolbox in the Python interface. So personally, I like to work on the Visual Studio Code, but of course use a Python application or programs of your choice. So I open Visual Studio here, and then a notebook. And the first things to do is to use the kernel corresponding to your Python environment. So here in my case is CMT kernel. So my notebook is ready. Then to use the toolbox, you must first import it. Import Copernicus Marine here. So syntax differs depending on whether you are using Python or command line. To obtain the equivalent of the help option in Python, you must first call the toolbox Copernicus Marine dot the function here subset, and then add a question mark here. So let's go back to the MyOcean viewer from earlier and look at the subset templates generated by the automate button here. So generally speaking, we recommend that user generate their data requests via the automate buttons in order to avoid many errors, such as entering a time range that doesn't include in this dataset. So let's copy the template for downloading from the Python environment and paste it in our cell of our notebook here. Okay, now I will also, Copernicus Marine, I will also add the output directory option to indicate the folder in which I want to find my data. And also give this subset a name using the output file name option, and for example, SLA within and see. And finally, let's ask the toolbox to launch the download directly without asking me for a confirmation. So to do this, we'll need to use the force download options, for which we need to add true. Okay. And then the download it starts automatically. And here I will find my data files in the indicated location here. So let's move on the latest feature of the toolbox, the open dataset and read data frame functions that can be used only from the Python interface. So let's first, let's open the options overview, Copernicus Marine open dataset here, and we notice that the writing of this query is very similar to the subset. The difference lies in fact here. The dataset will not be downloaded to your machine, but it will be open remotely. If I specify only the name of in the request calling the open dataset function, then the toolbox will remotely open all the data in this dataset. So for example, Copernicus Marine open dataset, dataset ID, and I will just copy the dataset name here, like this. So all the dataset will be open remotely. You can also create it and open your remote subset directly using these options shown in this help here, as the same way as the subset. So to show you that the syntax of this function is the same of the subset, you can also simply copy the subset query here and replace subset by open dataset. And now I will open my dataset in a variable, which I call DS4 dataset here. And you should also remove the force download opened output file name and directory option, which make no sense in this function here. Okay. So the subset can be, okay, make some time. So remember that the data is not downloaded here. To save your subset and in your computer, you can use the two netcdf options, functions that follows. And here you have to specify, I just want to copy my path here, because here you must to specify the directory in which you want to save your data and give it a name. And for a subset, for example. So now, see now my data files are saved in my folder. And the read data frame function is similar, except that it allows you to display your data in a data frame, which can be very useful when you want to open your data in the CSV format. A small warning, however, the data is no longer displayed in X array package, but pandas. It's strongly recommended to create your subset before opening the data, otherwise you will receives a message telling you that the data is too large for this format. So let's replace the open dataset function of our previous subset with the read data frame here, and see if the volume of this subset allows you opening in a data frame. Okay, here you get your subsetted dataset as a data frame. And just like the open dataset function, you can use the toCSV function to save your data in a CSV format. And there's my data here. So now we are explore all the function of the Copernicus Marine Toolbox. You should know that at present, not all the products are in our catalog are yet available via the subset function. We have a notification in our user notification service informing you the availability of the subset function for each dataset here. If you have any question or problem, please first consult the help center, and then if necessary, contact the user support by clicking on the widget at the bottom right hand corner of your screen. Thank you.
Thank you very much, Anaïs. So we have plenty of questions. Unfortunately, we won't be able to answer all of them today, but don't worry if your question is not answered today, it will be later in a post-event report, so don't worry. So the first one is from Luna. So she has two questions: if she can create a bathymetric grid from Copernicus data, and if from the package do you have both single beam and multi-beam survey available? So it's on QGIS. I don't know if you know that. Maybe we
not in QGIS.
Yeah.
It's not my.
Okay, no, we will see that tomorrow. We have a session with a QGIS tutorial, so we will be able to see that tomorrow. So what are the other parameters except sea water velocity and surface height that can be monitored using layers?
In the dataset, when you open your dataset in My Ocean Viewer, you can choose all the variables available in the dataset in the product. A product have different datasets, and in this dataset, you have different variables. So here I will present you the sea surface area and the seawater velocity, but there are many other variables displayed, and you can refine your search if you are interested for another variables.
Okay, thanks. There's a question about if my ocean dashboards are proprietary or do they run off external services? I don't know if you know that.
I don't know.
No, okay. Okay. So do you know if it's possible to download the data via RStudio, or is it only possible? Yeah.
Yeah,
Okay.
it's a use case subsection. You will find articles on how to use the toolbox in R, for example.
Okay, thanks. Up this one. Okay, so it's more a remark than a question. When you drew a confined polygon for an area, the time series you get shows which data. Is it like a spatial mean for each period?
If you yes, yeah, you have the average data of their zone on each graph of your object. So for lines and areas and points, you have some graph, and it will be displayed the minimum, maximums, and the average of the graphs.
Okay, thanks. Okay, someone is asking if there's a way to combine multiple datasets in Copernicus and download them as one dataset. I don't think it's possible. I'm not sure.
Multiple data sets and download
You can combine, not to download,
no.
afterwards only.
We have an options created files in the gates. Please consult the gates options. There is an options. I don't know now the name of the options, but you can create a JSON files in which you write the path of the different data you want, and then when you execute your JSON files, the toolbox will download this data. But I'm not sure if you can download data from different data sets or different products at the same time.
Okay, okay. Well, I guess it will be a surprise. And the last question for now, which other layers can be added and can we get a comparison data from two different information? I guess so, yeah.
Which layer can be added? Yeah, you can make a comparison with the different data layer, but I don't I'm not sure that I correctly understand the question.
Which one?
So
I'm not sure that we will keep that one on the side and we will answer them with a report,
yeah,
post-event report. Don't worry. We will take a short break and we will back at 11:35 with the first use cases presentation. So Katerina Spanozaki. So yeah, you can chat with other people in the chat or have a coffee or check our website. You can do whatever you want for the next 7 minutes and we'll be back soon.
bye.
Bye.
Thanks.
Welcome back, everyone. So before we start with the use cases, kind reminder to look at the survey we have on the website next to the Q&A section. We also put the link in the chat if you want to have a look. Yeah, so we will start with Katerina Spanozaki. And okay, yeah, you can see the poll right there. So yeah, it's next to the Q&A or on the link provided in the chat. So don't hesitate to go on it. So Katerina, when you want, the floor is yours, and good luck.
Thank you. Good morning, everybody. Thanks for having me here today. I will talk about a high-resolution digital twin we have built at Ford for the coastal area of Crete using several Copernicus marine service products. First of all, I'm working for the Foundation of Research and Technology, which is in Greece. My institute is the Institute of Applied and Computational Mathematics, which is based in Heraklion. Ford has more than 10 institutes scattered throughout Greece, and it's a multidisciplinary research institute, one of the largest in Greece. I work for the Coastal and Marine Research Laboratory. We deal mainly with operational ocean forecasting, marine pollution modeling, and almost all the processes that occur in the coastal zone. So coastal zone hydrodynamics, spatial planning, field surveys for the coastal zone, and so on. One of the main projects we're participating at the moment is Iliad, which aims at building one of the digital twins of the ocean for the European seas. And the research presented here today is part of this project. So we work mainly for Crete and Sea, both because we're based in Crete and Sea in Crete, but also because Crete and Sea is a very important ecosystem. It is a climate change hotspot. It's a very deep basin of the Aegean Sea, so it constitutes like a case study for the Eastern Mediterranean Sea. But it's also an area of high economic interest and human activity. There are recent exploitation activities for offshore oil and gas. So there are many end users in the area that always had the need for high resolution, high quality data that we can provide as scientists for the area. To answer some of these needs, we replied to one of the Mercator Ocean tenders for user uptake. And since 2021, we operate a high-resolution forecasting system for the coastal area of Crete. And we use hydrodynamic and sea state models that are both nested in Copernicus Marine Service products. And we provide a daily updated hourly forecast for almost all the essential ocean variables for our area. Although the service is still operational, through the Iliad project, we have enhanced service towards a digital twin. I say towards because this is an ongoing research. So we have integrated very high resolution weather hydrodynamic and wave forecasting models for several coastal areas in Crete. We continuously integrate in real time in situ metocean data from buoys, meteorological stations, and some novel sensors we have deployed in the area. And we also use satellite data, so we have a near real-time automatic oil spill detection system from Sentinel-1 data. This combined with the Lagrangian particle tracking models, we aim to warn early the authorities about potential oil spills. And there's a continuous integration interaction between the real system and the digital twin in order to always reinitialize our models and provide the most updated data to our end users. Coming now to the metocean forecasting system that we use, we use basically two models. So we use the NIMO ocean model for hydrodynamics, and we use WaveRouts 3 and SWAN wave models. These are nested in Copernicus Marine Survey products, but we also use for surface forcing. We deploy the weather research forecasting system. at a resolution of 3 kilometers for our area for surface processing. And we also use local bathymetry data in order to be able to reach the coast. We deploy a series of nested models in order to continuously reach a higher resolution, which are then verified by in situ data to be able to resolve the coastal hydrodynamics and answer to several questions that I will talk about later. From the Copernicus Marine Service, we use through the Python API, we use analysis and forecast products, so the Mediterranean Sea physics and the Mediterranean Sea waves. And we also integrate observations for satellite surface temperature, but also for in situ near real-time measurements. The reason, of course, for using the observations is to be able to calibrate and validate our models. So we routinely use satellite data for temperature in order to verify the hydrodynamics, and also oceanographic buoys that are operated in the area in order to be able to calibrate and test daily the forecasts of our wave models. In addition, in order to be able to go as close to the coast as we can, we have deployed a series of sensors that record wave parameters and hydrodynamics. This way, we're able to monitor one of the heat waves of the summer of 2023. It was one of the largest heat wave records from the Mediterranean Sea, where for our area we reported temperatures even higher, surface temperatures higher than 30 degrees, which was the highest ever recorded in history for our area. Now the user can access hydrodynamics, sea surface temperature, salinity, through Adam platform for daily updates and forecasts about physics and waves for our area. And then going to the very high resolution models that we have operational, so up to 5 meter resolution, we were able to build several applications. One of these is used by the region of Crete. It concerns rip currents prediction. So for this, we have tested this for a beach area in Rethymnon in Crete. So we go up to 5 meters in the coast. We have a survey about the slope and the bathymetry, which is very important if you want to predict rip currents. So we go from the Copernicus Marine Service, which is regional. We go to the sub-regional in the coastal area of Crete, and then to coastal scales up to the coast 5 meter resolutions, also including the interaction between currents and waves in order to be able to spot here at 3 specific locations of the coast dangerous rip currents. And of course, inform the authorities. Regarding marine pollution, also the very high resolution hydrodynamics and waves are very important. We were able to calibrate our models with observations from drones regarding microplastics, as you see here, and to be able to explain what is the process of these microplastics reaching the coast. So where are the accumulation zones and where we can apply very effective cleaning campaigns. So we went from the potential sources in the Mediterranean Sea and in the Aegean Sea to specific areas that are coastal, very high touristic areas for Crete. And again for, I think I missed a slide. Sorry. And again, now going to the digital twin, we have developed an automatic detection system, which when it is coupled to the very high resolution models that we have for Laplacian particle tracking and for hydrodynamics and waves, gives us a very good picture and early warning of potential oil spills. We use Sentinel-1 SAR data, which are pre-processed, and then for object detection, we use the neural networks, so an FCOS model, which is pre-trained with more than 1,000 SAR images, separated between oil spills, land and lookalikes, and ships. And then for the semantic segmentation, so for getting the oil spill mask, we use both SNAPI-based statistical methodologies and also a pre-trained unit model. So we're able to get a geotiff mask, which is then automatically imported in the oil spill model. And we are able to forecast oil spills that we were never able to do before for the coastal area of Crete, even small oil spills, like this is a very small oil spill from a ferry doing the route from Heraklion to Piraeus in the Aegean Sea in June 2023, which was missed by authorities in any other case. In addition, we have developed a deep sea oil spill algorithm, which is connected to the surface oil spill models. And this is for the offshore exploration that is happens at the south of Crete. And this is very important for early warning in case of an accident when the oil and gas operations take place in the next couple of years. And it really helps having a reliable high-resolution products for the deep sea. If you want to visit and follow the updates of our forecasting system in the digital twin, you can visit Iliad and the Iliad Marketplace. This is a website where you can find all the information regarding the service and the products that we use. And you can also find the forecasting service and the digital twin, and also access our data through Jupyter Notebook in the Atlas of the United Nations Ocean Prediction Decade Collaborative Center. This is the Atlas, and this is the website. You can access and see and download all our data, hourly data daily. Thank you so much for your attention.
Thank you very much, Katrina. It was a really nice presentation. We have a few questions for you.
Okay.
So we will begin, just waiting till it's there. Okay. So the first one is, can I make a real-time references of the Nigerian coastal zone hydrodynamics with Copernicus data? So I guess it's just like for your presentation.
Regarding the Nigerian coastal zone, yes, I mean, you can follow more or less the same procedure. I'm not sure which Copernicus Marine Service you would need to use for the for going from regional to coastal scales. I'm more familiar with the Copernicus Marine Service products that we use for our area, but regarding the methodologies going from region to coastal, yes, you can definitely do that.
Yeah, Daniel, you can look on our website. Everything is really well explained. We have another one for you. Can see sensors measure the readings of temperature, pressure, humidity, and can be produced in lab. Well, I guess so, yes.
Yes, I mean,
like,
the sensors that we use, yes, you can, and you can plot even with better. I have to say that since we have a digital twin, the way that we do it is we integrate, so ingest data in real time. The file format is ZAR, because we need to access specific parts of the data each time. So, and this is how we automatically integrate from the database. So this is an automatic procedure for us.
Okay, we will have one last question. So someone is wondering if there is somewhere in detail what parameters you used. So I guess in your paper.
Yes. So the parameters that we use from the Copernicus Marine Service are zonal inverted nodal velocities, sea surface height for initial and boundary conditions, and we calibrate with For the coastal scales, we calibrate with in situ data, but for the larger coastal area of Crete, we calibrate with the Argo floats and with satellite data for temperature.
Okay, great. Thank you very much. So that's it for you. For all the questions that haven't been answered, it will be on the post-event report, so don't worry. I will leave the floor to Augustine, Moses, G. Aguirre, and thank you again, Katrina, for your presentation. And the floor is yours, Augustine.
Thank you. Can you hear me?
We hear you. We just don't see your face. I don't know if you activate your camera.
It's just disappeared. I can't actually see any option to bring it on. The option has disappeared.
Okay. You can go without the camera. Don't worry. It's not
I
the
can
most important.
make it on. It was like on, but then it's like went off. Can you? Because I don't have control over my screen,
Yes.
anymore.
Don't...
So okay, so let me just turn it on now.
Oh,
so
it's good. Okay, yeah, you can go.
Is it on now?
Yeah, it's on. Yeah, thank you.
Okay, good. Yeah. So can you give me control to be able to control the slides? Hello? Yes. Yes, hello. Yeah, thanks so much. So if you can see and hear me, then I can just carry on from here. So I'll try to keep everything really briefly and just give a brief summary of the use case where we utilize the Copernicus Marine Environmental Monitoring Service and Products. And in this first slide, you could just gives a brief overview of the university where I'm currently working. So if you want to find out more, you can just Google it and then you can find out more information. So basically, I'll be presenting a use case where we utilize the Copernicus Marine Environmental Monitoring Services chlorophyll data to perform a multi-aquatic ecosystem assessment using Lake Ladoga as a case study. So first of all, we are mainly interested in to see if it is possible to be able to utilize global remote sensing data products to quantify or assess the impact of anthropogenic activities on ecological changes taking place both at regional and local scales, and specifically if it was possible to be able to extract useful information in let me say an aquatic ecosystem environment. So to achieve this, we carried out 2 studies, and then the first studies we published in this Journal of Census, and then it was translated and published in the local Finnish language in the book on your right, and then the second study was published also as a book chapter in this one you're seeing on your left. So first of all, we utilize the chlorophyll products of the Copernicus Marine Service, like I mentioned earlier, between 1997 and 2021. And then we try to see if it's possible to be able to extract something useful from this data set. And why did we choose it? We chose it because this data product is designed specifically to be able to assess or carry out research in turbid waters that are not clear and difficult to perform any kind of research from satellite. And for those who may not be aware, we also have the type 1 type water, which are more or less like clear. But in this case, specifically, turbid waters could sometimes be referred to as type 2 water bodies. And to analyze this data products, we use a combination of geostatistical and visual interpretation methods, which I will not be going into details there, but maybe later if there's time and somebody wants to know, then we could go into that. And then in this next slide, it gives you an overview of the study area where we carried out these studies. And you could see that in the first study, we carried it in 4 different levels. First, over the whole lake, and also in 3 subsampled areas. And we did it specifically to be able to avoid the potential of introducing bias into our results. And after this, I can just show you briefly what we did. In this first study, we were mainly focused at the regional level, which is like area-based. And for the data, we downloaded the data for the summer months of June, July, August, September, and October. And then we extracted the mean of the chlorophyll data. And then from there, we also calculated the mean of means and used that as a seasonal data set. And from that data set, we're able to fit these models, which we are seeing in this current slide here. And then from the whole lake and also in the subsampled areas, almost all the results indicated that there was actually a decrease in the chlorophyll content in Lake Ladoga specifically, which is not so drastic, but it's like moderate in this context. And then apart from this, we also did like a visual interpretation. I've selected some few pictures here, which you can see right now. It's able to give us a general overview of what it looked like visually looking at it. We could see that the coastal areas are more or less like seems as nothing has changed. And the areas that had the most of the improvement were like in the central part and in the northern part. But one setback or one drawback we had from this area approach was that we could not actually see locally what was happening. So we now said, okay, what else can we do? And then we now said, okay, maybe we could try something else. And then that's at the local level to see actually what is happening within the local areas around this lake. And that is when we now did the pixel-wise approach, which you now see in this current slide. And you can see with those red pixels throughout the time series, it fitted a Mankenda model that gave us like a magnitude of change, and then the sense slope, which gave us the significance of that change. And from what we did, everything was significant, as you see here. And if you look at the map on your left, so the negative and green are areas that indicates that there's like some improvement. There's less than chlorophyll A or in the water body of Lake Ladoga. And the red areas shows that, okay, there's high quantities. And the yellow areas are indicating that there's more or less like no change. And then just to show what we are able to extract from this Copernicus marine data products was these conclusions here that both the aerial and pixel-wise analysis gave similar results, which indicated there was improvement in the water body of Lake Ladoga, which was a good thing in this case, which we then looked at closely and said, okay, the areas around the existing pulp and paper mill, which is still functional, shows kind of like improvement, which we saw in the previous picture, the green pixels, which we could attribute to the better waste management, which you can see from the slide here, like those ponds circled in red. And then just to follow up on this, you can see from this next picture here that the pulp and paper mill is located where I have a yellow box. And if you look around, the surrounding pixels are quite green in this area, which shows that, okay, the management practices contributed to improving the water quality or the trophic state or the trend that we observe from this analysis here. And then just moving on, just a few more additional words that yes, there was improvement in Lake Ladoga. And then yes, the deeper parts showed better improvements, but the southern parts along the coastal areas showed little or no kind of like improvement, mainly because there's still self-loading of nutrients from the bottom part of the lakes, and also there's always like influx of nutrients. But in general, the situation is quite stable in Lake Ladoga in the last decade that we are under study, and nothing has drastically kind of deteriorated. And just to mention here that even though both of these case studies have indicated that, yes, there's improvement, but still there's something else that we could extract because the pixels here are like 4 kilometer by 4 kilometer pixels. So currently we are now working on a third study in the same location where we are going to use a different approach to be able to give us some more additional information because the surface water is behaving differently in the lake. So hopefully we can do that this year. And then we're also working on some other cases where we're going to use a lot of these Copernicus marine data sets in finished lakes. We have already identified about 5 lakes already. And hopefully that one we implement that coming 2025. So now, before I will leave, I would like to finalize that to answer our main question, that is it possible to use global remote sensing data set? Yes, from both of our studies, yes, indicated that yes, it is possible. And the data set provided by Copernicus Marine Services are quite useful and are shown that yes, it's possible. So having said that, I think I will stop here for now, and I would like to thank you all for your attention and time. So if there are any questions, then perhaps we could go a little bit more deeper. Thank you.
Thank you very much, Augustine. It was a really nice presentation. We have a few questions for you. So the first one is a really interesting one. So someone is wondering, so in DRC, the marine coast is characterized by coastal erosion, which degrades the ecosystems. You are a researcher, so how can we meet this challenge?
Well, I think I would say that, well, I don't know the current situation or the land use practices that are ongoing there, but basically when you're having erosion, it could more or less be related to the land use practices. Maybe there's deforestation, or maybe there are some other land use practices that are actually contributing to erosion. So maybe I would suggest that we should also look at the surrounding land use practices. Is there unsustainable farming practices, deforestation, or what is happening? Then based on that, we'll be able to formulate a solution. That's what I would suggest.
Okay, thanks. Okay. So someone is congratulating you, and they want to know if you also have in situ data to check your conclusions, and do you see some issues with the global color data set in these types of lake?
Well, thank you for the question. I would say that it was quite difficult for us to have any access to data from Lake Ladoga, and even the Russians did not even have data. It was quite difficult, but somehow we were able to validate our research by using some data from previous literature they use. So we're able to kind of like validate that, yes, what we researched and it was valid. So we use some data from past literature to validate our results. And I would say that the main issue with the global data sets, maybe I would say maybe the coarse nature, because if we look at the data set we use is 4 kilometer by 4 kilometer. One common issue we have with using coarse data is this issue of mixed pixels. So there could be some other small variability ongoing within those pixels, but now we cannot actually say because of 4 kilometer. But if we have like higher resolution, then we could extract much more better information. But this data set I can say is quite useful because it gives us a general trend and overview of what is happening. And I think it's quite good, yeah.
Okay, thank you very much for your response. Someone is also wanting to know if there is an explanation to what happened on August 2006, resulting in high chlorophyll mean concentration in the most part of the lake. I don't know if you know that.
Yeah, so I maybe not 100%, but I can have an idea because some years we are like unusually warm with some climate warming. So we could observe that when the period is unnecessarily warm, or not unnecessary, but unusually warm, then it promotes algal bloom, and then we have like higher chlorophyll content. So I think that's the most likable explanation I can give for that, because we have those kind of observations in a couple of years.
Okay.
Yeah.
And there's still more information on your paper, so
yes, exactly.
we invite people to read it.
Thank you.
So someone is wanted to know if your research can measure phytoplankton and eutrophication data as well.
If I understood your question correctly, I think that from the Copernicus marine data products, they have a lot of this data there. So if you want to look at the phytoplankton, and if you want to look at the dissolved organic content and all this stuff, so you could find a lot of data there. So there are some data sets that we will be using in future studies, but we did not necessarily use. And I can also mention here that we also tested the water surface temperature during its analysis, but it didn't show any particular trend. So we actually left it out. But this data set you could find in the Copernicus Marine Service product. So if you're interested, just have a look at that.
Okay, I think what was the unit used for representing the chlorophyll levels in the map? So I don't know which map.
I think it's referring to I think it's milligram, micromilligram, cubic milligram per milligram.
Yeah, I wasn't sure. Okay, thanks. Yeah, the usual.
Yeah, I hope I said that right. Anyway,
oh, sorry, I don't know it. So this question is more of a general question. Can this be expanded to other water bodies in the region? Do you have access to NASA PACE data, and does it cover lakes? So, well, I guess you could do your study in every type of other water bodies, but I don't know about the access to NASA PACE data, so maybe you know.
I'm not aware of what the NASA PACE data is all about, so I think I'll have to look into that, yeah.
Okay, yeah. And the last one, so do you use annual means for your analysis about the pictures you showed? I guess you did.
Yes, that's what I did. Yeah, we use annual means, yes.
Yeah. Okay, great. Well, for the question, we have everything. Before moving to Trank Show, so thank you very much, Augustine. It was a really nice presentation with really interesting question. Just a kind reminder to keep posting your question in the Q&A section, and to look at the polls and answer it. And also, we have plenty of questions about QGIS on the chat and Q&A section. Just to remind you, tomorrow we will have a session dedicated to practical session with Jupyter Notebook tutorials, QGIS, and RStudio. So be there tomorrow. It will be a nice session too. So thanks again, Augustine, and Trang, whenever you want, the floor is yours.
Thank you.
Okay, do you hear my voice?
We can hear you, yeah. Thanks.
Okay, I try to check with this line. Okay. Hello everyone. In short, my name is Trang Châu. I am from Laboratory for Science for Climate and Environment. And for 5 years, I have been as both data user and data provider for Copernicus Marine Service. And LSC is a research unit belonging to CA, the French Alternative Energies and Atomic Energy Commission, located in the south suburb of Paris, France. And LSC has contributed to research activity in the field of low carbon energy and nuclear and renewable in C8. Focusing on the 3 subjects for research in climate and environment. And today's presentation will introduce the use of Copernicus Marine Survey product for the improvements in observation-based estimation of coastal CO2 uptake and water acidity. This is the joint work with Marion Guerlain, Frédéric Chevalier from LSCE, and Nicolas Mezen from Lausanne in France. And some motivation and objectives of our research. Here, as we know, that human activity emits a huge amount of greenhouse gases into the atmosphere, and of which 50% is CO2, carbon dioxide. And at the beginning of the industrial era, the CO2 concentration were estimated lower than 300 parts per million, and CO2 emission have continuously increased, reaching nearly doubled, nearly 420 parts per million in 2020. And the increase in atmospheric CO2 concentration has been attributed to the occurrence of more and more climate crisis and extreme weather events that we have seen nowadays. And fortunately, the ocean have absorbed 20% of the atmospheric CO2 on average. Consequently, it acts as a climate moderator, produce the problem of global warming. However, analyzing CMM ocean monitoring indicator dataset, we have seen an increasing trend of CO2 uptake by the ocean between 1 and 1.3 petagram of carbon per year in the 1985 and to nearly doubled in recent years, and that corresponding to the rising of CO2 emission. And as the large, another side effect for ocean CO2 uptake, as the large amount of CO2 enter into the ocean, it leads to the changes in ocean chemistry. And one of the urgent concerns that has the direct effect on marine organism and marine ecosystem is ocean acidification, which is defined as a decrease in seawater pH. So having accurate estimate of ocean uptake of CO2 and seawater acidity, as well as other carbonate variables, would, for both open ocean and coastal region, would gain robustness on the quantification of atmospheric and land sink of CO2, on the prediction of global climate warming or global climate change, or on the monitoring of global of ocean health status. And the important source of estimation of global ocean carbon budget and many other variables in marine CO2 system is the Surface Ocean CO2 Atlas, database of PCO2, Surface Ocean Parcel Pressure of CO2. And PCO2 have been measured from different platforms. It can be from international ship trackings or from mooring buoy or uncrewed vehicles. And on the left figures, we show the spatial distribution of PCO2 data over the open ocean and over the coastal region. The coastal have been defined at within the 400 kilometers from the side, from the shore. And the colors illustrate for the number of data over the 38-year period per rig cells. For instance, near Japan Sea or along the ship tracks between Europe and Americas, we have around 50 or more than 50 data, which means we have more around 50 or more than 50 months over this period having observation of PCO2. So in general, most of the data have been measured over the North Hemisphere or near the large harbors or the trading areas, and some region in the south has no data. So on the right figure, we show the temporal distribution of SOCAT data, and we see the number of data increase over years, but had a tendency of reduction in recent years due to the measurement activity narrows. In summarize, SOCAT offers about 200,000 data over the open ocean at 1 degree resolution, and around 430,000 data over the coastal region at 1/4 degree resolution. And data coverage is too poor regardless, and the quantity increase over time. So we aim to reconstruct the BCO2 data over the global ocean at monthly and quarter resolution over the period since 1985. And we use a valuable data set of different environmental variables for the reconstruction of BCO2 and other marine carbon variables, including temperature, salinity, salinity high, miscellaneous depth, chlorophyll A, and CO2 mole fraction. Among these predictors, we use reanalysis products of temperature, salinity, salinity high, and chlorophyll from Copernicus marine surface. And deep learning was applied to derive the estimate of nonlinear relationship between BCO2 and environmental variables for each month. And data at SOCAT observation location is used to train and validate the models. And the data at non-observation of predictors are used to predict BCO2. Here, with a few tracks, we start with a few tracks of data each month, and using deep learning allows us to recover BCO2 maps over the global ocean. Then the reconstructed BCO2 maps is used to derive the estimate of air sea fluxes, which is the amount of CO2 exchanged between the air and the sea over the surface cell unit. In addition, BCO2 is one of the essential variables to estimate other marine carbon variables like pH, alkalinity, DIC, which is the inorganic carbon, and omega, which is saturation state with respect to calcium minerals. Here, this slide illustrates that we have distributed the data set of surface ocean carbon to cement Copernicus marine surface in 2019. Is the open source for use, and you can download the full data set or extract the time series over a specific location or region of interest. Data validation is available in the document here or in the relevant articles. Sorry, a bit fast here. This one, from this slide, we will explore the use of the reconstructed surface ocean carbon field. Compared to reverse version, our new high spatial resolution offers us much more data over the coastal region, say for example, or over the polar or subpolar region. So it means that we now have more opportunities for study of the carbon psychodynamics or underlying mechanism over the region, over the coast or subpolar polar region. And the higher resolution at quarter degrees outperform the description of horizontal patterns of marine carbon data variables. Thus, it would be a potential result for study of small-scale variation of the coastal urban ocean continuum or over the land and ocean transition. And here, for example, we exemplify the spatial distribution of the low resolution and the high resolution product over the strong permanent upwelling source of ocean CO2 near the South American west coast and over the strong sink of CO2 driven by the dilution of the freshwater at by the Amazon River outflow. And on the right figure, we compare the low and the high resolution BCO2 product at different sites near the North American coastline. And 1 degree is in gray. The colors show for the quarter degree. And so in general, we see that the high resolution product would offer the time series with greater temperature variability of the coastal BCO2, and that reflects the nature of strong and complex dynamics of the carbon cycle nearshore. And compared to BCO2, PHE rarely observed or subject to high uncertainty. So normally studies involved in the monitoring of ocean acidification and its effect on marine organism or ecosystem has used observation by data set of alkalinity and BCO2 DIC to derive pH, or pH can be measured directly. But for example, in Page et al. 2014, we see that estimated of the trend based on observation of pH, which show a short time period, and that abstract study on the temporal variability of pH. And with Copernicus Marine Service, we have access to the full coverage of pH over multi-year periods in 1985, and complement to pH observation to derive the estimate of short-term to long-term variation of pH and other marine carbon variables. In summary, this presentation gives us an overview of the two cases of using Copernicus Marine's product as using them as the predictors for the reconstruction of the new variables. And here we use the temperature, salinity, chlorophyll A to estimate marine carbon variables. And second, using Copernicus Marine Surface dataset of BCO2, acid fluxid, and pH for the evaluation of each spatial distribution, horizontal transition, or temporal variation, such as the trend, seasonal cycle, or interannual changes. And other potential studies include the attribution and detection of anomalies. For example, the recent study here show us that we have learned that the extreme heat wave events spread widely in the open ocean to the coastal sector of the northeastern Atlantic in June 2023, which had not observed in the previous year. And corresponding to the heat wave event, we observe an anomalous reduction of ocean CO2 sink in June 2023 back to the 2000 sink. And similar study we can apply for all the ocean basin and coastal region over the globe to have a study on the anomalies that coexist with or are driven by the climate extreme event. So thank you for your attention.
Thank you very much, Trang. We will move to the Q&A part of your presentation. We have a few questions. The first one, someone is wondering how many parameters you took for the CO2 emissions for the ocean. I don't know if you remember that.
What do you mean about the CO2 emission for the ocean? I'm not sure about the question, but maybe they ask for the predictors.
Perhaps, maybe they can. We will answer them later, and they can also look at your paper. But no worries.
Okay. So in case that they ask for the predictors, so we had used salinity, temperature, sea surface height, mixed layer depth, chlorophyll 8, and CO2 mole fraction. So more or less 6 to 8 parameters to estimate the surface partial pressure of CO2. And we also use latitude and longitude to localize the estimate of BCO2 and environmental variables.
Okay, thanks. Someone wants to know, was the dependent variable measured in situ, and was it a continuous data?
Okay, was dependent measured in situ? Yes, for BCO2, it is in situ measurement. And SOCAT offers continuous data, which is the data measured directly from ship from all the autonomous platforms. But the data we had used for our reconstruction is already the reanalysis data, which is the data have been rereaded, have been cleaned and qualified. So, for example, as I saw on slide, maybe slide 9 or 8, that we use the rigid version at 1 degree resolution, 1 degree and monthly resolution, and quarter degree and monthly resolution. But if you want to learn about the continuous data, it's also available online.
Okay. How did you validate the results? You can just say to look at the paper, but if you could give us a brief explanation, it would be nice.
Yeah, okay. So normally we have used SOCAT data to train, but we split the full data set into the three sections. The first one, 2/3 of the total data we use for training the models. One third we use for validation. And inside the design of the models, we also use the cross validation that exclude the data over the month of the reconstruction to over 15.
Okay.
So we try to split SOCAT in order to have the training data and validation data.
Okay, very nice explanation. Thank you very much. We will have one more question. So someone is thanking you for your nice presentation and asking if you use the COS2SYIS. I don't know what it is. I don't know if you know, Kizer, to derive. Yeah.
Yeah, exactly. We use COS2SYS, which is the tool, the nice tool to derive many carbonate system variables. So starting from the reconstructed PCO2 field, we use COS2SYS and other parameters like surface temperature, surface salinity, and nutrient also. And then we compute other carbonate variable like alkalinity, inorganic carbon, omegas, etc.
Okay. And just one last question, and then we'll move on. Someone wants to know how reliable is your data in the other regional seas. Don't know if you test it or if you have an idea, depending on how you realized your work.
I added in your new recursions. Okay. So we need to test in that. So
Okay.
yeah, we need to test it. But currently we have already the data cover the coastal ocean, and for Black Sea, I'm not sure, but for Baltic Sea, we already have the data on Mediterranean Sea. So over the first test, we see that the accuracy is quite good, but the uncertainty of the model estimate is still high, and we need to improve the model as well as adding more predictor or more data to see if we can have the more robust recovery rates of the data.
Okay, thank you very much. We will move on to the next presentation. To the people who hasn't their question answered, don't worry, we will do it in the post-event report after the event, but we have to move on to the next presentation. So it's time for Riccardo Martellucci. So whenever you want, the floor is yours.
Good morning, everyone. Today we are focusing on coastal phytoplankton bloom, and in particular the use of multi-dataset approach to deeply understand the coastal dynamics. I'm Riccardo Martellucci. I'm working as a researcher at the Italian National Institute of Oceanography. So let's move to a brief introduction about the coastal systems here. The coastal systems are among one of the most dynamic natural systems because in this place, the open ocean and the land interact at different temporal and spatial scale. So it's very difficult to understand the processes occurring in this marine environment. For this, the Marine Strategy Framework Directive suggests to implement the coastal observation using satellite in situ observation and model product. The object of this work was analyze the coastal phytoplankton bloom, adopting a platform approach, which integrate the Copernicus Marine Service product, consisting in satellite and model output, with in-situ data from a specific location and the specific monitoring area in the Tyrrhenian Sea, in the Western Mediterranean. Why is important to analyzing this coastal phenomena with this multi-platform approach? The first thing is that with the Copernicus Marine Service product, we can obtain data from satellite that give us the coastal open ocean extension, and with the model that give us also the coastal open extension and also the vertical dynamics along the open sea direction, while the in-situ dataset provide the local observation. It's true that there are some limits related to the model output, especially in the coastal area, as the model was tuned to describe the open ocean processes. But with this kind of analysis, we can be sure that the model product, as well as the satellite, can be useful for understanding this extremely complicated coastal processes. So here I want to explain a methodologist consisting in different steps in which you can follow this step to obtain a consistency dataset that can allow you to understand the variability of the coastal system. The first step is to define the processes in terms of variable that you can use to define the process you are looking for. In that case, we want to investigate the phytoplankton blooms that occur in the coastal area. And the first step is make a background analysis based on the bibliography, the available data set, in which you can follow the climatology of these particular blooms. Then you have to perform the data collection. In that case, we use the in-situ observation, the satellite data and model data from Copernicus Marine Services product. And then you have to perform some metrics that can be useful to understand if the model and the in-situ data present the same variability that can be useful to understand the coastal processes. Then you have to integrate all these variables one by one and enter the external drivers that can allow us to understand the variability we observed in our data set. So, in our case, this is the study site that was placed in the Tyrrhenian Sea. This is the area. And this is an area with high economic and environmental importance, hosts a very big touristic harbor. So there is a lot of pollution related to the coastal use. And the morphology was characterized by marine terrace. There are low freshwater input. And this is an aspect that we need to take into account, as we have to consider that the model was run consider climatology river input. So if we don't have any very big input, the amount of this water that can be really useful to understand the nutrient absorption in the area can be very tricky. So we can analyze the winds, because the winds produce the mixing in the coastal area, and the main current, and also the significant weight height. This parameter allow us to give the fundamental drivers for the phytoplankton variability. Then we can move to the collection. Here on top, you can see the observation station for temperature and then for the model. As the first approach, there is a very good correlation between the model and the observation in reproducing the typical temperature for the temperate climate in the the mid latitude. We have cold and vertical mixed winter. Then there are thermally stratified water, and you can see here how can the model can fit the period in which you don't have data for any case. In some case, the data at the observing station cannot be taken for better weather condition on something else. Same as for salinity. In that case, there is a very good agreement in terms of a linear correlation from salinity and observation and the model. And here you can see especially at the beginning of 2015, that there is an estimation of the low salty water present at the observing station, but this can be normal. Then we can move to the phytoplankton bloom, and then we have also satellite observation from the Copernicus Marine Services. Then we have the chlorophyll recorded at the observation station, and also the model product. Here you can see there is a good correlation in terms of reproducing the phytoplankton spring bloom, and there is obviously some differences in the absolute values of this variable. So let's move in the analysis in how we can perform these consistencies among this data set. And one of the most useful method to do this is apply the empirical orthogonal function that can give us an idea of how the variability of the model and the observation can be represented in this way. Here we apply this empirical orthogonal function for the temperature, salinity, and chlorophyll, and we clearly see that the model and the observation present the same trend in terms of variability of the principal component of the of this parameter. Then we can use the model product to obtain an idea of what is representativeness of the hour sampling station that is represented by this star, and with this model that we have before perform the consistencies, we have an idea of what is the footprint of our observing station. Then we can analyzing the driver of the phytoplankton bloom in terms of mixing of light, because we all, if you don't know, the phytoplankton is are primary producer, and these primary producers need light and nutrient to growth. So we need to analyze the light data, and we can use both the in situ data, but not only, and also the climate Copernicus data. And what's occur? Hello?
Yeah, the slide are coming back.
It's back. Oh.
1 second.
Wait 1 second.
Okay. So, and then we can obtain a synthetical view of this driver to build up the, with our proposed best quantity. We have some problem going further. Oh, what? Sorry. So we can use some threshold to define the drivers of this variability, and okay, and we can build up merging of the different data set to have a clearly representation of the coastal phytoplankton bloom. Here we have merged all the chlorophyll data to obtain this kind of representation in the satellite can be very useful to cover the surface and the coastal open extension of the phytoplankton bloom. Here we can see that these blooms are strictly related to the coastal, and the model provides us an evolution of the seasonality in terms of distribution along the open ocean coastal extension. And here with the driver, we can define the forcing that allow us to develop this kind of bloom. So, in conclusion, the use of this multi-platform approach that is obviously quantitative and supported by the proven of consistencies among these different data sets, give us an opportunity to deeply understand these coastal processes. And the Copernicus Marine Services provide this high quality data that can be matched to obviously statistical analysis to obtain an idea of what is a phytoplankton bloom in the coastal ocean. So, and another most important thing, that this method can be potentially applied to any multi-platform monitoring systems, and also not only for the phytoplankton dynamics, but you can also consider in the physics to deep understand the coastal processes at different time scale. Thank you.
Thank you very much, Ricardo, for your nice presentation. So sorry for the queue issue we seem to have. I don't know what happened, but in any case, well done. We move to the Q&A section. So we have plenty of questions for you. So the first one is quantitatively, how did you define a bloom event to be able to access its dynamic?
In our case, I have used a threshold of 1 milligram per liter in terms of chlorophyll abundance. So if I have some chlorophyll concentration greater than this threshold, I can define that we have developed of this bloom. This can be seen during the spring and also the autumn period, and define to be able to assess its dynamic. And I can assess this dynamic observing the evolution of this bloom. As an example, if you see, can you please put the last figure I have shown?
Okay, let's wait. Yeah, wait.
Not
thanks,
this.
Julia.
The slide. Oh, yes, that is.
Thanks, Julia.
You can see here. We have an interruption of the bloom. So to understand what is the dynamic related to this, I can, and like this for the threshold, I can observe, as an example, the wind stress and the wind reaction, and I have found that this is the effect of the coastal upwelling that move westward. In our case, the phytoplankton patch, I don't have an interruption of the bloom, but my data show this, but the dynamics is completely different because it was driven by a physical phenomenon that exchange these differences here you saw. Instead, in the 2017, as an example, I don't have nothing similar to this.
Okay, great. Thanks. Thanks for the explanation. Okay, we have one question. How does ship navigation affect the in situ? I don't know if you take this into account or...
No, this is a long-term time series in which we performed one profile per week at the same coordinates, and is the CSEM, cioè Civitavecchia Coastal Monitoring Environmental Systems, that is a multi-platform approach to study the coastal ocean in terms of biology and then physical processes, model output, and so on. And we merge all this data with the model output and the satellite observation to improve our knowledge about this kind of processes.
Okay, great, thanks. Okay, someone want to know if the in situ data you presented is from Boy. Or...
You can find the in situ data in the CDataNet portal.
Okay.
And maybe also, but I'm not really sure because I'm not working yet at in Civitavecchia, and I'm working at the GS, so I don't know if this data can be found also in the Copernicus in situ TAC data, but I'm pretty sure that also you can find there.
Yeah, I think so. Yeah, yeah. You just have to look a little bit, and you can find them. Yeah.
Thank you.
Okay. So. Another question, did you make a comparison between the data collected in situ and those by the EO Copernicus, unless with model you are referring to Copernicus data?
Every time I refer to a model, I refer to a Copernicus. If you see in the Hofmöller, there is the names of the product. In that case, I have used the temperature, salinity, and chlorophyll product from the Mediterranean model output.
Okay.
Provided by Copernicus Marine Services.
Yeah. Okay.
I use the Mediterranean product as an better resolution respect to the global ocean model.
Okay. Okay, I see. Thanks. So we will have time for 2 more questions. So the first one of the last one is, how does the integration of in situ observations, large-scale analysis, and forecasting systems allow us to better understand this interaction?
Okay, this is really important, and this is reflect the variability of the coastal phytoplankton bloom. If you have only one observation point, you need to understand something related to develop of the bloom in terms of blooming, increasing the bloom, or decreasing the bloom. But you have also to consider that this patch can move westward, northward, and in some specific case, I just show you before, you can have a decrease in the coastal, in the chlorophyll signal, but if you observe the satellite and then the model, you are pretty sure that this can be due to a feeding of zooplankton as an example, but a movement of this species through the that can be moved further from the coast. So in your specific point, you can't observe this. So if you integrate the data and if you are sure that the variability observed from the observing station and the model, you can be sure that the variability you observe in the observing system can be complete with this model and satellite in terms of observing if there is a movement of this phytoplankton patch. So this is a better way to understand the development of the bloom, especially if you want to compute the primary production and these other terms, because having only one observation point reduce your ability to understand this type of coastal processes. So this is one of the best way to understand these processes, because your view is complete in terms of lateral processes, lateral advection, and so on. And this is need to be taken into account when you are dealing with this kind of study, because otherwise you can underestimate some things that, and especially what occurred in the observing station, can be not true.
Yeah, I see. Okay. Thanks very much for the nice response. We have time for the last one, and then for all of the questions that haven't been answered, it will be in the post-event report. So the last question is about the negative effects of algae blooms and zooplankton. So,
negative effect of algal blooms mean like harmful algal blooms or something related to this, because fortunately in the Tyrrhenian Sea we don't have experience of the harmful algal bloom, but you can use the satellite observation to define the sites and the class sites of the marine phytoplankton. Then you can understand these in terms of marine succession of phytoplankton species, following the work of Margalef and Strada, an example in which you have the suggestion from diatoms, coccolith, and dinoflagellates during the summer.
okay.
Then zooplankton. The zooplankton product can be very useful to understand the marine food web, obviously, but during that time I do not sample zooplankton and I do not perform any analysis of the zooplankton. But I think that merging the drivers and the observation, you can obtain an idea in what term the phytoplankton affect these blooms.
Okay. Yeah, okay. I see. Thank you very much for your response, and thank you for all the question. So we are reaching the end of today's session. So thanks a lot to our 4 speakers for their great presentation of use cases, and thanks to everyone who do a presentation and went here with us. Before we leave, I just want to remind you that there is a section on the on the website next to the Q&A reserved to the polls, and I would really like to have your feedback on today, and we could provide what we could provide in the future. So please take 2 minutes of your time. That would be really helpful. For all of the questions that haven't been answered, we will try to answer them as fast as possible on our post-event report. So thanks again for your patience. For tomorrow, it's going to be more of a practical session with Jupyter Notebook, QGIS, and Air Studio tutorials. You can see they are available in full on the event website. There is a tab at the top, as you can see there. So you can find them and you can download them, and there is also the full video tutorials of the tutorials. If you don't have time to do them, you can just look at the videos. And tomorrow these tutorials will be presented by 2 people from Now Systems, so Alvaro de Pascual Collar and Stefania Siliberti. They will be there to answer your question. And well, we hope you're there as well, because we saw that there was plenty of questions about our tutorials. So thank you very much, everyone, and we will see you tomorrow. Goodbye.